We're in a race against time to protect life on our changing planet. We're drawing lines on maps, we're creating protected areas, but what if the main tool we're using to do that has a fundamental, critical flaw? Well, let's get into it. The stakes? They couldn't be higher. We're talking about the risk of losing up to half of all species on Earth. Forever. That's the reality we're up against. So, what are we doing to stop it? And this is where we hit a really strange paradox. See, we are setting aside more land for conservation than at any other time in history. But with climate change rewriting the rules, are these protected areas actually doing the job we need them to do? For decades, the strategy has been pretty straightforward. Build fortresses for nature. Think national parks, wildlife reserves. But what happens when the very ground these fortresses are built on begins to shift? Can a simple line on a map really protect a species that's being forced to move? To figure out where to build these fortresses, scientists use a tool called gap analysis. It's kind of like laying two maps on top of each other. One map shows where a species lives, and the other shows our protected areas. The whole point is to find the gaps, the places where vulnerable species have no protection. Okay, but here's the problem. It's a really big one. For years, we've been caught in what this new research calls a binary trap. We've been taking the beautiful, messy, complex reality of nature and reducing it to a simple black and white picture. And in doing that, we're losing all the most important details. This really lays it out perfectly. The old way of thinking is like a light switch. A habitat is either suitable or it's not, on or off. A species is either protected or it's not. But the new approach these researchers are proposing, it's like a dimmer switch. It lets us see all the shades in between, the full spectrum of a habitat's quality, from 0 to 100%. So here's how we've been getting it wrong. First, scientists use these really sophisticated computer models to predict where a species could live. But then, in step 2, we do something kind of crude. We basically take all that rich data and squash it into a simple yes or no. And just like that, poof, all the crucial nuances is gone. And don't just take my word for it. The authors of the paper, Ibrahimi and her team, put it plainly. This conversion to yes or no leads to significant information loss. Think about it. It's like trying to climb a mountain with a map that only says mountain or not mountain. You'd have no idea where the cliffs are or the valleys or the safe paths. You'd be flying completely blind. So, how do we fix this? Well, a team led by conservation scientist Dr. Alam Ibrahimi has come up with a really brilliant solution. They call it a fuzzy approach, and it's all about tossing out that simple light switch and embracing the complexity of nature to get a much clearer picture. This is really where the dimmer switch shines. Instead of that simple yes or no, you get a continuous score. We can finally see how suitable a habitat is. This lets us do all sorts of cool things, like compare the specific needs of different species, or track if a particular area is getting better or worse over time. It allows for so much smarter planning. All right, so the theory sounds great, but does it actually work in the real world? Well, the researchers put their new tool to the test. They focused on a group of animals that are right on the front lines of climate change, 45 species of amphibians in Southwest Asia. So first, let's look at the before picture. This map shows us the world as it is today. Those green areas, those are the prime hotspots for these amphibians in places like Turkey and Iran. This is their home turf. And now, here's the future. Climate change just completely redraws the map. The homes they have today, they start to degrade. But look, new potential habitats start to pop up further north. You can see it right there. These animals are going to be on the move. Now, this is where it gets really interesting. If we were still using that old black and white light switch method, we'd look at this future scenario and probably feel pretty good about it. In fact, the old method would tell us that even in the future, 60% of these amphibians will still be inside protected areas. 60%. Sounds like we're doing okay, right? Yeah, I mean, if 60% are still covered, problem solved, right? Our existing protected areas are doing their job just fine. But is that the whole story? Well, this is the devastating catch that the new dimmer switch approach reveals. The old method misses the single most important detail in this entire story. Sure, the amphibians are still technically inside the park boundaries, but the quality of their home, it's in a total freefall. This chart shows a steady, relentless decline decade after decade. It's like their address hasn't changed, but their house is literally crumbling around them. And there's another incredible insight this new approach gives us. It helps us figure out where our uncertainty about the future is coming from. And the answer is it's stunning. A whopping 85% of the uncertainty has nothing to do with different climate change scenarios. It comes down to which scientific model we choose to use. So what do you do about that? The solution is something called an ensemble forecast. Basically, instead of betting everything on one model, you combine the results from many different models. It's like getting a second, third, and 20th opinion all at once. It gives you a much more robust, much more reliable prediction of the future. So, what does this all add up to? Look, this isn't just about a new fancy scientific tool. This is about a whole new way of thinking about what conservation even is. And honestly, it's a total game changer. Here's why this matters so much. This new approach helps conservation planners find the spots that will be high-quality homes for wildlife, not just today, but decades from now. It gives us a real science-backed roadmap for meeting huge global goals, like protecting 30% of the planet. But most importantly, it forces us to shift our focus away from the quantity of land we protect to the quality of that protection. We have to start redefining what the word protected even means. It can't just be a static label we stick on a map and then walk away from. True protection has to be dynamic. It's a living, breathing measure of a habitat's ability to support life, both today and tomorrow. And that leaves us with the final, and I think most important question. If a protected area is no longer a good home for the very species it was created to save, can we really say that it's protected at all?